a Milwaukee Packout vacuum cleaner. Now, a guy called Scott sent me this. Apparently he's got a couple of them that have got the same fault. And let's just show you what the fault is. So we've got a full battery here. I'll just put the battery in. And there's a power switch on the side with 2 speeds. I don't know if you'll be able to see that. Probably not for the angle that we're at the minute, but oh, it's absolutely dead. No life whatsoever. So let's have a look and see if we can repair it. So it looks like we've got a number of screws around the top here. I'll see if I can get this top separated from the bottom so it's not as tall on my bench, so we'll get a better view of things. So I'll just see if I can arrange that now and then I'll be back. Right, so I've just removed the bottom of the unit and flipped it over. So I'm just going to remove this part here. See if we can get that out of the way. This is where the filter goes, and it's got a little float valve thing there. Let's just check that the motor's not seized. That seems to turn around nice and freely. Actually feels like a brushless motor, this. Be interesting to have a look inside of this then and see what's actually in it. Let's see if we can get into it this way. Alright. Let's see if I can remove this vacuum hose. So yes, it is a brushless motor. And it looks like we've got a control board down here. I wonder if I can get this off the base so we can get into it a bit better. Alright, let's see if we can separate the switch and stuff from the one. Oh, looks like that's just unplugs. I think it'll just make it a bit easier to work on the bench. Does this slide out? Yes. Right, so that's that bit out of the way. I'll see if I can get this switch to pop through. Right, get this bit out of the way now. And I think that's going to be a lot easier to work on now. Let's try and organise this a little bit. Right, tell you what, we'll zoom down a bit on this board. Right, so it looks like we've got some MOSFETs here to drive the brushless motor. And it looks like we've got some MOSFET drivers here. Looks like a small microcontroller. I'm not sure what that IC is. Looks like a voltage regulator here. That's about it really. There's not really much else on here. So why is it not working? Right, I'll just zoom out a fraction. I'll plug the battery in. Let's try and zoom down a fraction more. We'll just see if we get any power on this voltage regulator. So, ground is here. We're just on volts DC. Try the switch the other way. Unless that's a different, no, that's the battery ground. I've got a small fuse there by the look of it. Tell you what, I thought that's ground. So that's the power supply coming in. What do we get on this side of the fuse? Right, so the fuse is okay. But it doesn't appear that we're getting any voltage to this voltage regulator. Let's just measure that again. Right, okay, we've got power there. Looks like we might get power there for a brief moment. Let's just try switching it on and off with the meter probes on. Interesting. So it looks like we get a brief surge of power and then it shuts off. Right, see if I can get rid of some of this conformal coating off some of these chips so we can get a better view of them. And see what these chips are and that voltage regulator. Right, I might have to bring the microscope in on this so we can get a bit better view. Right, I'll just go sort that out. Right, let's have a look over this board then. So the power comes in here. Looks like it goes through a fuse. It's hard to see with the coating on this, the conformal coating. We've got this component here, which I thought was a voltage regulator, but it may actually just be a transistor. And that looks like it goes to some Zener diode there and a resistor. So it may be being used as a voltage regulator. What's that then? AS, it's a bit hard to see the number on that. Oh, there we go. AS339M. I'll have to look up to see what that is. Another IC here. An MV358. So I guess that's probably an op amp like an LM358. Looks like there's two tracks come off and go underneath this current sensing resistor. That's more than likely a MOSFET driver, because there's three of them, or probably a dual MOSFET driver, and then that heads up over towards the MOSFETs, which are just up here. I'll try and zoom out a fraction. Now I think Scott's already had a little go at this, because I've noticed on some of these MOSFETs, it looks like they've been touched up, like that one there, and possibly this one here. And that one there. So one of those looks like IR2103S. But I can't see anything obvious at the moment. I can't see any blown components or anything. Or this is where the switch signals come in from the switch, just on these three pins here. And we've got these two pins which go over to the battery for communication with the battery. And what's the main microcontroller here? It looks like an STM32F030K6T6. Looks like we've got a voltage regulator here, I would say. But I can't see anything Like I said, I can't see anything obvious on this. I think the next thing to do is to try and switch it on. We'll see if we've got any voltages going to this microcontroller. So we have a debug header here, it looks like, or programming header, which I guess is for programming the microcontroller here. This looks like ground. Actually, not that one looks like ground. And this looks like supply because it comes from this voltage regulator here. So it looks like it comes from the voltage regulator through the capacitor here, under that diode, and then round to this point here. So let's see what happens if we switch it on. Well, I heard a little dink sort of noise from the motor there. Let's try that again. It didn't do it that time, but we did briefly get power to the microcontroller there. I'll just try that again. It doesn't seem to want to do it now. Well, that was interesting. It did briefly power up for a second there. Right, so at least we know we're not getting power to the microcontroller. Let's see if we're getting power to the voltage regulator. It looks like we might have a test point. It's a bit hard to see with this conformal coating. I think we've got a test point here, which looks like it goes to the capacitor and then to the voltage regulator. Let's just try. Let's see if I can get on there a bit better. Right. Try and dig into the coating. Yes, well, I did get a brief flash on the meter there. I don't know what voltage it went up to because I was trying to, I was looking at the microscope picture and I did hear the motor try and start again. I'll switch that off and we'll try it again. Right, so we're briefly getting power there and then the power seems to be switching off. So the question is, where does the power come from? Does it come from here? Right, let's try over here then. Let's see if I can. Let's try this pin here. Right, so we do get a brief meter reading there, but then it seems to stop again. Let's see what's happening on this pin. Again, we get a brief pulse. So I think this transistor here switches power because there's a electrolytic capacitor on the opposite side of the board here. That then feeds the regulator, which then powers the microcontroller up. So what controls this? No, I can't see where that goes. It goes, looks like through a, or to a diode there and through a resistor. I can't see any other tracks that feed into that. And the track goes along here, but I'm not sure where it goes after that. So I'm just going to unplug the power a second, and then we'll try testing some of these components. So I've got the meter set to resistance mode, and we'll just check this resistor here. Yeah, 750 ohms, it's okay. Let's see if we can work out which one's ground. So I'll just go on the ground pin here. Right, so this is ground, and this must be the power coming in. So I'm not sure what switches this on. I wonder if we've got power here all the time or not. I'm just going to see if we've got power on this transistor here. No. So how does the power get to here? Because I mean, I would have thought that would be powered up all of the time. Because I mean, it's a fair sized transistor, so something must be switching power to it. Let's see if we've got any power further up here. Right, well we've got power here, so I guess this is the power rail coming across the top there. Yeah, it looks like it heads over from the battery. It's just a bit hard to get this in focus again. Yes, right, so that's the power rail coming in here. Right, tell you what, if I go onto this pin here, do I get power when I switch this on? No. And again, I'm not quite on this contact. Or is this the ground? Let's try this side of the resistor a second. Right, so we've got power there. And we'll get power there for a brief moment. I'm just wondering what would happen if we sent power to here. If it would spring into life or not. Or if it's a problem around here. I'm not exactly sure how this gets switched on, you see. I guess the signal from the switch, which is down here, somehow comes through this lot and ends up here maybe. That's the only problem when you don't have a circuit diagram for anything, you're just trying to work it out. So it takes a little bit of time to try and get your head around exactly what's going on. Right, might be a bit tricky to do this. I've got my meter probes poked into the header connector here, or debug connector, or program and header, or whatever you want to call it. And I'm going to try and send some voltage into here, where it gets switched to, just using this meter probe. Right, so that gives me 3 volts, but it still isn't working. I'll just try switching on to one of the modes. And that still isn't doing anything. So we should be getting 3 volts of that microcontroller. I'm just going to try and see if I can set the thermal camera up, just to see if anything's getting hot. I'm just going to try and balance the thermal camera there. And we'll try sending voltage across again. Well, something's getting hot there, but I think that's just the 3-volt regulator. Which is just here. So yeah. Let's try moving the camera along a little bit. There's another component getting warm there, which is that component there, which is that Zener diode. But I don't think that's the problem. I mean, we can measure it just to see if it's shorted, but I don't think it's that. I'm just wondering, I've had a similar problem with I think it was one of the work lights that I looked at a while back, and what it was doing was it thought the battery voltage had dropped below a certain voltage, which is why it wouldn't power on. It was using the battery voltage, sending it through a potential divider, which is just a couple of resistors, and then sending it into the microcontroller. And if the voltage was below a certain voltage, the microcontroller obviously thought the battery was flat and then wouldn't switch the unit on. So I'm just wondering if it's something similar with this. So there was some white silicon over this part of the circuit board here. I thought I'd remove it just to have a look what was under there. And it looks like there's a little thermistor marked RT1 here. So that must be for measuring the temperature of the heatsink in case the unit overheats. And that seems to go down this track here and into this op amp. And I guess that then sends the signal to the microcontroller here. So if it starts overheating, it shuts the system off. I don't know why it's dropping power. We seem to have power there initially, and then it just seems to disappear. It's like it's switching itself off. So I'm just wondering whether it's something like the battery voltage detection, or if it's something like the overcurrent protection kicking in. I wonder what happens if we disconnect the motor and power it up, just to see if that does anything. I've just tacked a little ground wire on here so I can attach my meter probe just so it's easier for measuring voltages and things. I think I'll try that. I'm going to disconnect the motor and then we'll see if that has any effect on anything. So one thing I haven't explained, which people might not know, is how these motors actually work. This is a 3-phase motor, or a brushless motor, and what happens is the microcontroller switches these MOSFETs in sequence to make the motor either go one direction or the other. So what happens is one of them switches positive and one of them switches negative. So you might say like this one will switch positive, that one will switch negative, which will send power up these 2 wires. And then that'll switch positive and that'll switch negative, which will send power between that wire and that wire. And then the same sort of thing will happen again, where it might be that one and that one. So they kind of go along together like that in sequence, and that'll either make the motor go around clockwise or anti-clockwise. That's basically how they work. It's pretty much like that anyway. Right, let's disconnect this motor. I'm just wondering if it's something to do with the overcurrent detection. So, right, if I use my little clip here, and if we go on to the 3 volts, well, that's interesting. It's not shutting off there now. and I can hear something going like did on this circuit board. It sounds like it's trying to switch something. I wonder if the problem's with the motor. I mean, these should be very low resistance in any case because it's only like a coil of wire. Let's just see. .3, yeah, I thought it would be very low. 0.3. Now which two didn't I do? That was between that one and that one next, I think. .3. I mean, it's possible the motor, but I find it unlikely. I'm just wondering if it's something to do with the current detection on there, which will probably be that IC there. I might connect the oscilloscope up and we'll have a probe around on some of these pins here just to see if we can see anything going on. Right, I've got the oscilloscope hooked up. So this comparator here seems to measure the current, and it seems to go in on the bottom 2 pins here, which I think is comparator number 1, I think, or comparator number 2. And the output of the comparator are these 4 pins at the top here. So let's see if we get anything on any of those. Let's switch it on. I can hear it clicking, but we're not getting anything on that pin. Let's try this pin. Right, we seem to be getting a pulse on there. Yeah, we seem to get a few pulses and then it stops. Let's try this pin. Again, we seem to get a set of pulses. Let's try this one. And again, a set of pulses. Now, I know this motor doesn't have any Hall effect sensors, and they normally use those for feedback. It's like if you have an electric drill and you need to go slow and, you know, measure how much torque you're putting on it, they usually use Hall effect sensors to do that. But because this is just a vacuum cleaner, they're using a brushless motor that doesn't have Hall effect sensors. So I wonder if they're using this chip to get feedback from the coils of the motor, so it knows the position and when to fire the next set of MOSFETs. That may explain why we've got 3 waveforms there, and I think the other one is the current sensor output. Tell you what, let's just hook the motor back up and we'll just try repeating those measurements again. So if I go into that pin, which I think is the current, well, I heard the motor go dunk and then nothing else. So I'll just give it a second and I'll try that again. We only seem to get 1 pulse and then it stops. Let's just try this one. Again, just a little tiny bit of a pulse there. I'll just give it a second just to reset itself. Well, that's a bit bizarre, isn't it? I wonder what we're getting on these MOSFETs. Tell you what, I'll disconnect the motor again. Let's just try going on the gates of these MOSFETs. We'll see if we get any signals. Yes. Right, I'll just turn the voltage down a bit on the scope. Right, so we've got a waveform going on that pin. Let's try this one. Yes. Yes. Let's try these ones. Yes. Oh, it looks a bit odd. Let's try this one. So, it seems to be triggering the MOSFETs, it just seems to be cutting out. The motor's not jammed, is it? I'm sure I tested it to see if it wasn't jammed. No, the motor's moving around. I'll just zoom out a bit so you can see. Maybe you see the back of the motor turning there. And I haven't got any other brushless motors to test. I'll tell you what I could try. I've got this light bulb here. Let's see if I go under there and I'll just go onto the battery positive there. Let's just see if the light bulb flashes. Right, okay. Let's just try the next one. Right. Right, so that will be, because I'm on the positive here, that'll be the negative MOSFET switching. Let's just try the positive side then. So if I go on to the negative here, now it should flash because it should be switching the positive voltage through these MOSFETs. No. That's strange. It's like the positive switching MOSFETs aren't actually switching. I'll just disconnect the battery a second. So the negative comes in here, goes through that current shunt to here. So that's the negative, and then when the base, when the gate of the MOSFET gets switched, it switches it from there to here, which is the output. So that's how it switches the negative. On the positive side, the positive comes in, I guess, on the tab, and then switches through to this pin to the output. Let's just see if we've got, yeah, we've got continuity from there to there. We've got continuity from there to there. That's a little bit puzzling, this one. Why aren't these ones switching? Right, well, this is a bit bizarre. I've just got my negative of the bulb just hooked up here, just so it's easier instead of trying to clip it onto this point here. So the battery comes in on this red terminal, on this red wire here, goes to that terminal there, and the black comes into this point here. If I go onto here, bulb lights up, as expected. It goes through the fuse, and then to this point here. Bulb's not lighting up. It does here, but not there. I'm sure I've checked that fuse, and if the fuse was gone, how come the rest of the board's powering up? That just doesn't make any sense. Let's just measure this fuse again. I'll just connect the battery. I'll have to look back at the video. I'm fairly sure I checked this fuse. 2.4 ohms. I'll just connect the battery back up again. Yes. No. That side of the fuse lights up, and that side of the fuse doesn't. Well, I've not had that before. This is a new one. I wonder if this is one of those resettable type fuses and it's sort of half failed, where if there's too much current, I don't know, it's a bit bizarre. I'm fairly sure it's that fuse. That's the only thing that makes any sense, because I mean that's a 21 watt bulb, so it's going to draw less current than what the motor would. And I suppose that would explain why the circuit board's powering up with the motor disconnected, because it's not drawing enough current to kind of trip this fuse. I think this fuse has partially failed, which is why it's measuring, but as soon as there's any current goes through it at all, it's just going open circuit. And like I said, I've not had that before. Right, so I'm going to take that fuse out and see if I can find an alternative. So there's the old fuse removed, and one of the ends has actually just fallen off it. But if I turn it over, we've got a bit of a black mark on the back of it. So I think this has partially failed. So it was letting some current through, but as soon as it was going over a certain amount, it was just going open circuit. Like I say, it's partially failed, which is what's kind of give with the odd symptoms that we've had. Right, I'm going to see if I can find a replacement. I'll see if I can find out what amperage this is. Right, I think that fuse is a 30 amp. So I've had a look at the specifications of the vacuum cleaner, and on the label it says it's 18.3 amp. So they might have gone with 30 just for surge when it's first powered on. So I'm going to err on the side of caution and use a 25 amp fuse. I've just got one of these little automotive fuses here. I've just put a bit of heat shrink on it, and I'm just going to solder it on just there, because I haven't got any 30 amp surface mount fuses. So I'm just going to solder a wire onto here. Try and get past the conformal coating. And we'll just go onto the battery terminal. So something a bit like that. Right. Let's hook the motor back up and let's see what it does. Need to plug the battery back in. Well, I wasn't expecting that. I thought that was off, but it was actually on. Right. Right, so I think that's both the speeds. That's the first speed. And we'll try speed 2. Right, I think that's pretty much it. So that fuse was partially faulty. Right, I think I'll assemble it and we'll give it a final test. Right, it's all back together. Let's pop the battery in. Let's just check the switches on still. Yes. Right, let's give it a little test. Now I haven't got the filter for it, so that's one of the things I'll have to get. I'll just move it out the way a little bit. And we might as well use it to clean up the bench a bit. And there's the old fuse. Right, I think that'll do for that one then. Right then, if you enjoyed this video, please give it a thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.